بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. Today our new topic is speed of sound. Speed of sound. Before starting the new topic, I will explain the previous things, which is the first one is there are two types of waves. One is mechanical wave, the second one is electromagnetic waves. Those waves, mechanical waves, are those waves which require a medium for their propagation. For example, sound waves or mechanical waves or water waves. Electromagnetic waves are those waves which do not require any medium for their propagation. Light, like light, X-rays, microwaves, these are electromagnetic waves. Mechanical waves are of further of two types. One is longitudinal waves and the other one is transverse waves. Longitudinal waves are those waves in which particles of the medium vibrate about their mean position parallel to the propagation of waves. And transverse waves are those waves in which particles of the medium vibrate about their mean position perpendicular to the propagation of waves. You already studied in class 10th. Now, speed of sound. Speed of sound is the distance covered by sound wave per unit time is called speed of sound wave, speed of sound. Just like the simple speed is equal to distance divided by time. Speed is speed is a longitudinal wave in nature or compressional wave, as I told you the definition. So the speed of mechanical waves depend upon two things. Number one, density of the medium, and the second one is elasticity of the medium. So Newton derived this formula for the speed of sound. Speed is equal to under root elastic modulus of the medium divided by density of the medium. One question related to this: the speed is directly proportional to the square root of elastic modulus and inversely proportional to the square root of density. Now the question arises in mind that in which medium like solid, liquid or gases, the speed of sound will be greater. So the speed of sound is greater in solid than in liquid or in gases. Now, why this speed is greater in solid than in liquid or in gases? Because this density and elastic modulus. First of all, elastic modulus is the ratio of stress to strain. The ratio of stress to strain you have already studied in class 9 physics. Stress is force per unit area and strain is the ratio of change in length per original length, or it is the measure of deformation produced in a medium. It is the measure of deformation produced in a material is called strain. So elastic modulus is the ratio of stress to strain. So elastic modulus of solid is greater than liquid and gases, and density of solid is also greater than density of solid is greater than liquid or gases. So the ratio of E and rho, this rho is density, E is elastic modulus. So the ratio of E and rho in solid is greater than in liquid or in gases. So when we want to explain this, So you will have to explain with the reference of formula. In the previous classes, you just learned it that the molecule in solid are very close to each other. They are closely packed, so energy can easily transfer from one place to another place. So that's why the speed of sound in solid is greater than in liquid or in gases. But in this case, in this class, you will have to explain with the help of this formula. Is it clear? I hope this will be clear to you. Now, Newton assumption. Newton assumed that the sound travel through air and other gases under isothermal condition. Now, iso mean same, thermal mean temperature. When the temperature of the system remain constant, this is called isothermal process or isothermal condition. So when sound, according to Newton, when sound travels through air and other gases under isothermal condition, the sound travel under isothermal condition. Under isothermal condition, modulus of elasticity is equal to the pressure. We will derive this now. So, let V be the volume of the air at pressure P. If we increase the pressure from P to delta P, delta means our small change. Delta P is the change in pressure. P is the original pressure, initial pressure, and volume is decreased. When we increase the pressure, so there will be decrease in volume. So V is the initial volume, V minus delta V will be the final volume, and delta V is the change in volume, keeping the temperature constant according to this, isothermal according to isothermal condition. So this then by applying Boyle's law, as you study in chemistry and in physics also, that volume of a given mass of a gas is inversely proportional to pressure by keeping the temperature constant. So this is the relation for Boyle law. PV is equal to constant. In P we place P delta P, and in place of V we put V minus delta V. By simple multiplication, PV will cancel with PV. So we get P delta V is equal to delta PV minus delta P delta V. Now therefore P delta V, P delta, in this case delta P and delta V is very small. Delta P is the change in pressure, delta V is the change in volume. There is very little change in pressure or little change in volume. So the product will be very small. So we can neglect this term. When we neglect this term, we get only P delta V is equal to delta P into V, which is given in next slide. So therefore, P delta V is equal to delta P into V. Now, when we find the pressure from this formula, pressure is equal to delta P into V divided by delta V. We can write it as also, according to mathematics equation, delta P divided by delta V divided by V. When we invert this relation, so this delta V by V, we get again this equation, delta P by delta PV divided by delta V. Now delta P is the pressure, having the same formula just like stress. Stress is equal to F, stress is equal to F over A. This is the formula for stress, F over A. So stress is force per unit area, and pressure is also when force acting perpendicularly on area is called pressure. And this is, as I told you earlier, delta V by V is the strain, but volumetric strain. If there is change in length per original length, that will be Young modulus. That is called Young modulus. Or now that is called linear strain. Volumetric strain strain is delta V by V. So the ratio of stress to volumetric strain is equal to elastic modulus, which is equal to E. Next, so when we put the formula P is equal to E, so we get V is equal to under root P divided by rho. So P is equal to, now we can put P is equal to rho m g h, which is clear from this derivation. P is equal to force per unit area, F is equal to W is equal to mg when we, and M is equal to rho into volume. Volume is equal to mass, density is equal to mass by volume. When we cross multiply, so we get mass is equal to rho into V. Rho, this is equal to rho is equal to rho into V. Now volume is equal to area into height. So by putting the value of M, this mass is equal to rho AH in this formula, we get F is equal to rho AH into G. By putting this F in the first equation, we get P is equal to rho AHG divided by A with cancel, A with cancel with this A. So we get P is equal to rho GH, which is this formula. P is equal to rho GH. Now, if P is equal to rho GH, here M is for mercury, density of mercury, and we get, as we find the pressure by using barometers. So mercury is used mostly, mercury is used in barometer, and its reason is it is dense and has a low vapor pressure. The vapor pressure of mercury is low and it is dense too. So that's why mercury is used. So by putting P is equal to in this rho mgh in this formula, we get P is equal to under rho mgh divided by rho. Now rho m is the density of mercury at standard temperature and pressure. These are the fixed value at standard temperature and pressure. Like at standard temperature and pressure is equal to 1 atmosphere. Temperature is equal to 0 degrees centigrade or 273 Kelvin. So we put this for mercury, rho m is equal to 36.13.6 gram per centimeter cube. G is equal to 980 centimeter per second square, and H is equal to 76 centimeter. This is the height of mercury in the tube. So density of air is this one, 0.001293 gram per centimeter cube. By putting the values in this formula, we get V is equal to 281 meter per second. Now 281 per meter per second is different, is there is difference in the this value and the experimental value of the speed of sound in gas, which is equal to 332 meter per second. So there is the theoretical value. This value is 16% less than the experimental value. 16% less than the 16%. 16% less than the experimental value. Experimental value is 332 meter per second. Now, the Newton assumption was wrong because there is a very big difference between the theoretical value and experimental value of the speed of sound in gas. So another scientist, mathematician, a French mathematician named Laplace. Laplace corrected the speed of sound in gas by by giving the different points, different reasons, like sound waves are longitudinal waves which consist of compression and rarefaction. Compression are the portion in a medium where the particles are overcrowded, and rarefaction are the portion in a wave in a medium where the particles are not so overcrowded. Mean there is a distance between more distance between the particles. 8. A compression, the temperature of air rises due to increase in pressure. As there is increase in pressure, we know that pressure is directly proportional to temperature. So when pressure is increases, there will be increase in temperature, because at compression the particle will be come closer to each other. So there will be increase in temperature, there will be increase in pressure, and due to increase in pressure, there will be increase in temperature. And at a rarefaction, there will be cooling effect, mean there will be low temperature. Temperature doesn't remain constant, hence Boyle's law is not applicable. According to Boyle's law, temperature remain constant, but according to Laplace, temperature doesn't remain constant, because at compression the temperature is high and at rarefaction the temperature is low. So that's why the temperature is constant. And another reason, there is very less time for the flow of temperature for the flow of heat from compression region to the rarefaction region. This is because of air is a very poor conductor of heat, and the speed of sound through it is high, that is 330 meter per second. During the compression, air cannot lose heat and cannot gain heat during rarefaction. So as there is no loss and gain of heat during compression and rarefaction, so it means that there will be change in temperature between the two regions, compression and rarefaction. So as a whole system, the temperature of the whole system will not remain constant. And as there is no flow of heat from one place to another place, yeah, or there is no loss of heat or gain of heat. So this process is called adiabatic process. You will study this in detail, inshallah, in the last chapter, chapter number 11. So the last chapter is chapter number 10. In chapter number 10, you will study about isothermal process, adiabatic process. So, for adiabatic process is that process in which no heat enter or leaves the system. So, in this case, according to Laplace, this process is, in this case, when sound wave travel through gases, so there will be there will be no application of isothermal process. Adiabatic process will be employed. So for adiabatic process, PV power gamma is equal to constant. This relation is just like Boyle law, but only there is a power which is gamma. This the value of it is vary for different gases, for monoatomic gases, for diatomic gases, or for polyatomic gases, its value is different. We will study later, inshallah. So this question is very important for your paper. If this question come in short question, that write down the Laplace correction about the speed, for the speed of sound in a gases. So you will write these points just. You will write the point, you will write the formula. There will be no need of derivation. And if this question come in long question, you will have to derive the formula. So we, inshallah, I will discuss it later. Now, if if the pressure is increased from P to delta P, P plus delta P, P is the initial pressure, P plus delta P is the total pressure, and delta P is the change in pressure, and volume is decreased from V to V minus delta V, then we have PV gamma. This is the first relation. PV gamma is equal to, in place of P, we will write P plus delta P. And in place of V, we will have to write V minus delta V. But in this case, this is just like Newton assumption, but the difference is only here is power gamma. So P plus delta P, when we take common V, so the power will also come over it. V power gamma into 1 minus delta V divided by V power gamma. So V will cancel with V. When we take common V will cancel with V divided by we get 1. And minus delta V by V, where here we get delta V by V. Now for this term in equation 1, we will have to apply V gamma will cancel with V. So we get P is equal to P delta P 1 into 1 minus delta V power gamma. Applying binomial theorem and neglecting the square and higher power in terms of delta V by V. This is binomial theorem. Mathematics students study it in class first year. 1 plus x power n. So 1 plus this n power will come in first, n x divided by 1 pictorial. 1 pictorial mean 1 plus n, this power n into n minus 1 into x square. This is x square, this is x, so power is x square second term. In this case x power 1, in this case x power 0. So this is 2 factorial. 2 factorial mean 2 multiplied by 1. 3 factorial mean 3 multiplied by 2 multiplied by 1. In descending order you will have to go. 4 factorial mean 4 multiplied by 3 multiplied by 2 multiplied by 1. Now there is no need of further explanation for this. You will have to neglect the higher power of delta V by V. In this case, in place of x, in question there is delta V by V. And in question there is negative sign. When there is negative sign, so there will be alternate sign in the formula. 1 minus, here will be plus, and another will be minus. This is the formula basically according to binomial theorem. So 1 minus gamma, you just remember it like this, n here and into x. So 1 minus power into delta V over V. When we multiply this, simply P will cancel with P, neglecting this term. This is also again a small term, delta P, delta V are small. So when we neglect this, we will get this formula, P will cancel with P. So delta, gamma delta P by V will be equal to delta P. Now gamma P is equal to delta P where delta V, we can write this is as what? Gamma P in left side, delta V by V in right side. Delta P is again stress, and volumetric, delta V by V is the volumetric strain. Another one, I told you linear strain. Linear strain, Parlin not, that is tensile strain, but you will study in second year, inshallah. Tensile strain is the change in length per original length. Change in length per original length. But volumetric strain is what? Change in volume per original volume. Now, this formula P is equal to minus gamma delta V, this is plus delta P, we get gamma P delta P by V stress divided by volumetric strain. That is again the equation. So V is equal to, in place of E or in place of P, we will put the in equation 1. This is equation 1, P by rho. Now in place of P, we will put what? In place of elasticity, we will put gamma P. So gamma P divided by rho under root. So P is again equal to rho mgh. So I have explained this is in detail, but in the gamma is new. Gamma value is 1.42. So the answer will be 333 meter per second. Now 333 meter per second is closest to the experimental value. This agree with the experimental value. Experimental value is 33, 332 meter per second. So therefore, Laplace correction must be correct. Now, the effects of various factors on the speed of sound in air. Sound waves are compressional mechanical waves. Compressional mechanical waves are longitudinal mechanical waves, as I told you in the start of lesson. Propagating in gas or air with, with a speed of v is equal to under root gamma p over rho. Yeah, this we derived this equation. So it depends upon density, speed of sound. If pressure is constant, gamma is constant because gamma is changed for different gases. For different gases, its value is different. If pressure is constant, gamma is constant, then V will be inversely proportional to square root of density. So density effect of density. Effect of now effect of various factors on the speed of sound in air. Sound waves are compressional waves propagating in air or in gas or air with a speed of v is equal to under root gamma p divided by rho.